This is a nightmare to most students when it comes to differentiating between the horizontal surface and the inclined surface. Uh, I'm gonna clarify some things about these two here. So let's start. Let's say that we have an object resting on a rough horizontal surface. Once they start saying rough, that means there is friction. And excuse me for the noises outside. I'm recording this in December while people are celebrating their things, but here we have to learn, and I hope they don't affect the how we teach here. And once they say the surface is rough, just know that there is friction. Once they say surface is smooth, there is no friction. So in both surfaces, there is friction. And what are the forces acting on this object while it is at rest, not moving? We have a downward force, which is force of gravity. We have a upward force, which is the force on the surface here. If gravity is pulling this object downwards, then normal force it is pushing it upwards. So the normal force and the Fg are always, not always, but most of the time equal. And when we calculate the normal force, we use the mass times gravity. So if one should find the normal force of this object, we will say mass, which is 5 kg, times 9.8, which is 49. So 49 Newton is the normal force of this object here. And for the gravity, Fg, the equation is the same, or the formula is the same here. We just say Fg is equals to mass times gravity. And remember that gravity or gravitational acceleration is 9.8 meters per second squared. Don't try to memorize this because you are given in your formula sheet. It's here, 9.8 meters per second squared. So you don't have to go and memorize this all along. And when we calculate friction, we say the coefficient of friction times the normal force. And we can expand it and say the coefficient of friction times mass times gravity. So these are the formulas we're gonna need for the horizontal surface, a surface from left to right or from right to left. We're gonna use these equations here. And for the inclined, when a box is resting on an incline, we have a normal force on this surface here, a normal force which pushes this object a little bit upwards, and we have Fg here, and we say that normal force acts perpendicular to the surface. So your normal force cannot be like this, it cannot be straight like this. So 90 degrees to the surface. We have a gravity here which acts vertically downward. So what is different about gravity here is that we have two components of gravity. The first component is the Fg perpendicular and the other one is Fg parallel. Let's talk about it here. If I leave this object here, tomorrow when I wake up, I might find it here. But when I leave it here, I will never find it here unless someone pushed it up to here. So what is the force that allows this object to slide down the incline? Of course, it's the Fg parallel. It makes this object to slide down always. It does not make it slide up. So what is the force denying this Fg parallel to make this object slide down? Of course, it's friction. When we have friction on the surface here, then this object will not slide because this friction is against the motion of this object here. And remember that friction does not allow two objects to slide against each other. So remember that without friction, there is no motion. I mean, we can barely walk, and every time we try to walk, we will fall. And what I want to say again is that the coefficient of kinetic friction, the coefficient of static friction is always greater than the coefficient of kinetic friction. To think about it, ask this question yourself. When you push a car, is it hard when you start pushing it, or is it hard when you start pushing it when it is already in motion, when it is already moving? So is it hard when you start pushing it, or is it hard when you push it while in motion? And the correct answer for that is, it is very easy to push it while it is moving than to push it while it is at rest. When you start pushing a car, you have to exert a lot of force, because that car needs to stay where it is forever. And when you start pushing it, it is very hard. But once you start moving, you can even push it with one hand like that, because the coefficient there decreases. That's why we say the coefficient of static friction is greater than the coefficient of kinetic friction. So let's continue here. And the work of FG perpendicular is to make sure that this object stays on the surface. It does not float. It stays on the surface. Since this object exerts a weight on the surface, then this surface here exerts the same force on this object. We call it the normal force here. And in the previous video, I think we said that when you do the forces in the x direction, we use cos theta, and when you do the forces in the y direction, we use sin theta. But why do we use sin theta on FG parallel, and why do we use cos theta on FG perpendicular? Well, there is a mathematical reason we are doing that. Let me show you here. I've drawn the same object, but this time here I made it big. This is the same object here. We have a normal force. We have I broke down the FG here into its components. We have the perpendicular component and we have the parallel component. And if you look at this one, you can see that this angle here is theta. If you look at these two triangles here, this triangle and this triangle, they are the same. This angle here is the same as this angle here, and this angle here is the same as this angle here. And if you remember, in grade 10 or grade 11, you did the soccer true. The soccer true. And it states that sine is equals to opposite over hypotenuse, and cos is adjacent over hypotenuse, tangent is opposite over adjacent. So how do we use this here? We say that, what is sine theta here? Let's say sine theta. Sine theta. Sine theta is equals to, what is opposite? Opposite is FG parallel. Opposite is FG parallel. And what is hypotenuse? Of course, is FG. FG. So we can see that, let's cross multiply here. We can see that FG parallel is equals to FG sine theta. But what is FG? We talked about FG here. We said that FG is mass times gravity. So we can substitute it. We can say FG parallel is mass times gravity times sine theta. So this is the reason we use sine on FG parallel and we use cos on perpendicular. So what is cos of theta? Cos of theta is, we have adjacent. What is adjacent? Adjacent is FG perpendicular. FG perpendicular. What is hypotenuse? Is FG. So we can cross multiply. We can say FG perpendicular is FG cos theta. But what is FG? We say that FG is mass times gravity times cos theta. So this is where the equations, these formulas originate from. And one way to calculate the coefficient of kinetic friction or the coefficient of static friction, we say that the coefficient is tan theta. But how did this tan theta come? Where did this tan theta come from? Well, we have, let's look at the horizontal forces only. Since these horizontal forces are in different directions, I'm gonna say Fg parallel minus friction is equals to 0. Why 0? Because this object is not moving, so all forces are balanced. When all forces are balanced, that means Fg parallel is equals to a friction. So you can say Fg parallel is equals to friction. And let's go to the formula for friction. We say that mathematically, if Fg parallel is equals to friction, then friction is equals to Fg parallel. So the formula for friction is the coefficient of friction, let's say coefficient of friction times the normal force. Remember that the normal force is mg cos theta. It must always balance with the Fg perpendicular. So we say F is equals to the coefficient, let me leave the F here, and mg cos theta. So, but what is F? F we say is Fg parallel. So let me do this. Fg parallel is equals to the coefficient times mg cos theta. What is Fg parallel? Well, we go back here. We say that Fg parallel is mg cos theta. Mg cos theta. Mg cos theta is equals to coefficient mg. No, it's not cos theta, it's sin theta. I don't know why I wrote cos theta here. Let me cancel it. Let me say mg sin theta is equals to coefficient times mg cos theta. Since mg is in both sides, we can cancel it here. So we are left with sin theta is equals to coefficient cos theta. So we can divide both sides by cos theta, so that we have the coefficient on its own. Cos theta, they will cancel, so we are left with that the coefficient of friction here is sin theta over cos theta, and we all know that sin theta over cos theta is tan theta. So if they say calculate the coefficient and they do not give you anything but the angle, so you will say the coefficient is tan of that angle here. And this is what I wanted to talk to you about. You can see the formulas here. We say that the normal force is mg cos theta. I explained why. Fg perpendicular is also mg cos theta. Fg parallel is mg sin theta. Fs max or static frictional force maximum is the coefficient times the normal force, and you can expand it. We have the kinetic friction is the coefficient of kinetic times the normal force. You can also expand it here. This is what I wanted to talk to you about. In the next videos, we'll be talking about the Newton's laws and how to solve some questions based on them. And yeah, I will see you later.